How many grams of silver are in 0.148 mole of silver? First of all, you need to remember that mole is defined in 5 ways, and one of the ways is that mole N is equal to mass over molar mass. So remember. Yeah. So if I know this, to get mass is simply, I'm giving mole to be 0.148. So let's make mass subject of the formula. Mass now becomes mole times molar mass, mole, which is N, times molar mass. So that we now get 0.148 times the molar mass of silver is around, that is the atomic mass. I told you for elements you talk about atomic mass, for compound you talk about molar mass. It's the same thing, molecular mass. So it's 107.9 gram. I know that physics makes use of gram. This one is which means that this is going to give me, that's molar mass of it is gram per mole. This one is in mole. So mole will cancel now, left with gram. So you are getting, let's punch it. If you punch that on your calculator, you will have so if you punch that, you get 15, you have 15.9692. So that's approximately 16 gram. So looking at the question said, the second part is, how many atoms of silver are in this number of moles? That is, and remember I told you that look at the question. They said the second part is, how many atoms of silver are in this number of moles of silver? So remember I told you that the second way the chemists define mole is that mole is equal to number of atoms all over Avogadro's constant, which is 6.022 times 10 raised to the power 23 atoms. So which means that if I'm asked to find how many atoms, all I need to do is to make how many atoms subject of the formula, so that this becomes number of atoms is equals to mole times 6.022 times 10 raised to the power 23 atoms of silver, which is the same thing as saying 0.148, because we are giving the mole and they're asking us number of in this mole, number of atoms in this mole. So that we now have times 6.022 times 10 raised to the power 23, which is going to give me, when you punch it, you should get let's punch it. So you get, well, you're going to get 0.8913 times 10 raised to the power 23. So and this is going to be the number of atoms. So, and this number of atoms, you simply write it as, so this is going to mean particles. So I want to leave my answer this way. Question 2. This is question 1. 1B. So let's say that this is our B part. So question 2 now. Over to question 2. Question 2 says, how many iron atoms are present in a small slab of iron weighing 95.8 grams. How many iron atoms are present? So first of all, asking us how many iron atoms simply means number of atoms as well. So remember that N is equals to number of atoms all over Avogadro's constant, which is 6.022 times 10 raised to the power 23 particles, or you say atoms. So if I know this, I need to remember. Look at this. They gave me an iron, what the iron is weighing. What the iron is weighing, they say that it is weighing, that's the mass of the iron, mass of iron. So mass of iron given to me is equals to 95.8 grams. So that is the mass of iron given to me. It is 95.8 grams. So remember that if that is the case, we remember that mole is equals to mass over molar mass, because they did not give us mole, and what we need to make use of in this formula is mole, not mass. So we need to convert the given mass. You use what you have to get what you don't have. We need to convert the mass to mole, so that this becomes N is equals to 95.8 all over. Now the molar mass of iron is 55.8 grams per mole. So if I know this, by the time I do the division, I'll be getting that the mole is equals to 1.72 mole. So this is what I need. Now carry what you've gotten here and substitute for mole, so that I have 1.72 equals to this formula. So number of atoms over 6.022 times 10 raised to the power 23 iron. That is the number of atoms of iron I'm looking for. So this now becomes number of atoms. And making number of atoms, so the form number of atoms will be equals to 1.72 times 6.022 times 10 raised to the power 23, which is equals to, if you do the mass very well, this will give you 10.4 times 10 raised to the power 23, and this is approximately, if you take this let's do it well. Okay, atoms or particles. I'll leave my answer like this. I'll leave my answer here. Remember that we make use of mole, so we got mole first using the mass given to us. So let's say in case you did your own and you got something like 1.04, then times 10 raised to the power 24 atoms. You are still correct. You are still correct. Remove this, you drop this. So let's move to question 2. We've solved question 2. Sorry, let's move to question 3. So they say glucose C⁶H²O⁶ is the most important nutrient in the cell for generating chemical energy. What is the mass percent of each element in glucose? So when I want to find mass percent, we remember that in chemistry, number 3, we define concentration in a number of ways. We define concentration as the proportion of solutes in a mixture. So we define, since it talks about both mass, volume, and solute and the rest, define it as in terms of molarity, then molality. We also define it in terms of solutes per solvent or solute percent. We define it in terms of mass percent or part per mass, part per mass or parts per mass. So also part per solute. So we also define it in terms of parts per volume. So all these things I'm putting here now, the knowledge will help us in answering this question. So this place I see glucose is the most important nutrient in the cell for generating chemical potential energy. What is the mass percent of each element? I need you to know that before you can find the mass percent is simply getting mass fraction, then multiply it by 100. So all I need to do is to say glucose, just turning. Okay. So glucose, which is C⁶H²O⁶. So first of all, what is the molar mass, molecular mass of this? So 12 times 6 plus 1 times 12 plus 16 times 6 is equals to should be giving you around 180.16 gram. So gram per mole. You know the unit of molar mass is gram per mole. So it should be giving you this. So when they ask you the mass percent of carbon in this compound, all you need to do is to remember that carbon itself has an atomic mass of 12. So if it has atomic mass of 12, and then they ask you of each element there. So carbon has atomic mass of 12. Hydrogen has atomic mass, or you call it molar mass. I like to use atomic mass for elements, then molar mass for compound. Hydrogen has 1. Oxygen has atomic mass of 16. So all I need to do is to get the mass fraction first. And mass fraction is simply equals to you doing what's it called? Taking the mass. Okay, notice that in this particular compound, carbon, yes, the atomic mass is 12, but in this compound is existing as 12 times 6. Hydrogen here is existing is 1 atomic mass, but in this compound is in 12 places. You need to know this. This is the molar mass, the same as the number of moles of this particular element. Carbon here has 6 moles. Hydrogen has 12 moles. Then 6 moles of oxygen can be found inside 1 mole of glucose. So if I know this, by the time I do 12 times 6 for carbon, finding for carbon now, I will have carbon to be equals to 76. Then for hydrogen should be 12, while oxygen, if I do 16 times 6, by the time I do 16 times 6, I should be getting 96. So the minute I get this, notice in the ratios that they are, the minute I get this, to get the mass fraction now, mass fraction of carbon, mass fraction is simply the atomic mass, or you say molar mass of elements all over molar mass of compound. So which means that to get the molar mass, which means that to get the mass fraction of carbon is simply going to be 76. That is, mass fraction of carbon inside glucose will be 76 over 180. because that's the molar mass of glucose. Then to get the molar mass of hydrogen is going to be 12 over 180. And to get the molar mass of oxygen is going to be 96 over 180. So let's punch it. To get the mass fraction, sorry, I'm saying molar mass. So to get the mass fraction, so let's do 76 divided by 180. I'm trying to beat time. 0.4222 blah 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 blah. I'll do it in 2 days, but please. So let's do 12 divided by 180. I'll get this to be equals to 0.666 and so on. So let me approximate it to 7. Now let's do 96 divided by 180.16. I'll get 0.16. I forgot to be putting the 0.16. I'll get 0.53229. So sorry. If I do 76 divided by 180.16, I should get 0.42118. And if I do 96 divided by 180.16, I should get 0.5329, correct? Okay, so this is the mass fraction. This is how to get mass fraction. So you simply get the molar mass of that particular element in the compound, and when you get it, you divide it by the molar mass of the compound. So that is what we've done here. So now if they tell you to get the mass percent, all you need to do is on mass percent is equals to mass fraction times 100. So if I do 0.4218 times 100, I'm getting 42.18% carbon. So the mass percent of carbon is 42.18. That is what I'm getting for carbon, 42.18. Then if I do 0.667 times 100, I'll get 6.67 okay percent for hydrogen. Then if I do 0.5329 times 100, I'll get 53.29% oxygen, hydrogen. So this is what I'm getting. This is how to go about it. So that is for percentage mass. So now that is for number 3, question number 3. So over to number 4, question number 4. They said an organic compound weighing 5.714 gram produced 13.92 milligram of carbon dioxide and 2.951 milligram of water upon combustion. Calculate the weight percent of carbon and hydrogen in the sample. Please do not forget to like, subscribe and share. What we are doing is giving solution to your textbook problems, chapter 2.